Okay, students, now next topic is page replacement algorithms. So, when a page fault occurs, so first of all, let us understand what is page fault. See, as we have discussed, our virtual pages will be mapped with physical uh, page frames in physical memory, right? But the size of physical memory is less than virtual address space. At that time, we cannot accommodate all the pages into our physical memory simultaneously. So, whenever any instruction trying to access memory reference and that page is not available in main memory, that is called page fault. So, at the time of page fault, now operating system has to choose a page to evict or you can say remove from the memory. So we'll make a free page frame or room for the incoming page. If the page to be removed has been modified while in memory, it must be rewritten to the disk to bring the up to date copy. And already it is up to date, then no rewrite is needed. In short, here operating system required some mechanism to choose a page to evict or you can say remove from the physical memory. So once we remove, one of the policy is pick a random page, right? For example, we are having total 8 page frames. So total eight virtual pages and remaining 8 are unmapped or you can say not in main memory. And uh, currently, suppose we have referred page number, or we can say total 8 pages 1 to 8 in physical memory, but remaining 8 are not in physical memory. And suppose one of the instruction has referred page number 12 and that is not in main memory, so we have to so operating system has to choose a page to evict from the physical memory. For example, it has taken randomly page number 5. In page number 5 is what? Suppose heavily used page like Google home page and evicted from the memory, right? So what happened? At very next instruction, we required that page again into the physical memory. So we have to load that page again into physical memory and it will generate extra overhead. So instead of selection of random page, what operating system will do? Operating system will perform or you can say apply some selection policy. So we can minimize number of page faults. It is similar kind of scheduling algorithms, right? In scheduling algorithms, we are having so many ready processes, and we are having only one CPU. So scheduler will schedule, or we can say decide which process will be executed next or CPU is given to which process next, right? And will select process in such a way so we can minimize turnaround time, minimize average waiting time. So this is the goal of scheduling algorithms. Same way here, there are some mechanisms which is used to choose a page which is not heavily used, and that policy is called page replacement algorithms. And there are so many page replacement algorithms, and aim of each and every page replacement algorithm is what? It must minimize number of page faults for given reference string, right? So there are different page replacement algorithms which is used at the time of page fault to evict the particular page from the physical memory. Now we'll discuss one by one different page replacement algorithms, and for the same reference string, the page replacement algorithm which generates minimum number of page folds is the better algorithm for uh, page selection, or you can say better page replacement algorithm. So now we'll discuss one by one different page replacement algorithms. Next page replacement algorithm is optimal page replacement algorithm. The optimal page replacement algorithm is the best possible page replacement algorithm. The basic idea behind this algorithm is that whenever a page fault occurs, some pages are in memory. Out of these pages, one will be referenced at the next instruction, while other pages may not be referenced until the execution of a certain number of instructions. It means you can say your pages are labeled with number of instructions. So suppose page number 5 will be referred after 100 instructions. Page number 4 will be referred after 50 instructions. Page number 3 will be referenced after 25 instructions. So the page which is at most distant future is replaced, or you can say the page which is referenced at last will be replaced, right? Then we can say the page with highest label is referenced from the memory. So let us try to understand with example. So in this example, there is one reference string. Reference string shows particular pages, virtual pages referenced by instructions in particular order. So here reference string is 50535250107, and we are having number of 3 page frames, right, in physical memory. So at most we can accommodate 3 virtual pages, not more than that, right? So suppose reference string is given in our example is 505 and so on, and we are having 3 page frames, we can see in our example. Now suppose we are applying optimal page replacement algorithm. So first instruction refer the page number 5, and all the page frames are empty initially, right? So there is no pages available in initially there is no pages available in our page frames, or you can say physical memory, right? So whenever page number 5 will be referred, there will be a page fold. That is we have indicated by P at last, red P, right? So at the reference of page number 5, there will be a page fold. Then we can say next page is 0, but again 0 is not available in physical memory. Page number 0 is not available, so again it will cause a page fault. Now next page in our reference string is page number 5, but now page number 5 is available in main memory, right? So there is no page fault. So whenever page fault occurs, we'll mark as P, and last will calculate total number of P's in our reference string. So next page is P, there is no page fault. Then next is page number 3, and page number 3 is not available in physical memory, so there will be a page fault. Next page is page number 5. available in main memory, there is no page fault. Then next is page number 2, which is not available in physical memory, so there will be a page fault. But here the problem is what? Now all 3 page frames in our physical memory is full. So if we want to load a page frame, page number 2, then we have to evict one of the page from the physical memory. So either 5 or 0 or 3 we have to remove from the memory, right? So now we have to apply one of the page replacement algorithm. So here in our example, OS is using optimal page replacement algorithm. And according to optimal page replacement algorithm, we'll check which page is least used, or we can say which page is far from the recent instruction. So let us check 5. So 5 will be used at very next instruction. So we will not remove. After 5, 0, and again 0 is used. But page number 3 is used at the last, we can say. So page number 2 will be replaced with page number 3, because page number 3 is far from the 2 as compared to 5 and 0, because 5 will be used at very next instruction. So if we'll remove with 5, then again at very next instruction new page fault will be there, and we have to load page number 5 again. So instead of that, what will replace? Will replace with page number 3. Why? Because page number 3 will be used after 1, 2, 3, 4, 5 instructions. But 5 will be used at very next instruction, and 0 will be used after 2 instructions, right? So 3 is far from as compared to 5 and 0. So we'll replace with 5. The next page is page number 5. But 5 is already is in main memory, so there is no page fault. Next is 0. 0 is already in main memory, so there is no page fault. Now new is 1. Next is 1. But 1 is not available in main memory, so there will be a page fault. So again now we have to decide which page we should replace. So 5 is not there, right? So 0 is referenced at very next instruction. Then after 0, 3 is there, but 5 is not referenced, right? So we'll replace page number 1 with page number 5, okay, instead of 0 and 3. The next is 7. Again there will be a page fault because 7 is not available. So we'll replace with 0, because 0 is not shown in reference string, means it is not used frequently, or we can say in after few instructions. So we'll replace with 0. Then we'll replace again next page is 3, and 3 is not available in physical memory, so there will be a page fault. So we'll replace with page number 2, okay. So in this way optimal page replacement algorithm will work, and whenever we are using page replacement algorithm for this given reference string, there will be a total 7 page faults, right? So now for the same string we'll apply another algorithms, and we'll try to check how many page faults are there. And the page replacement algorithm which generates minimum number of page faults is the best algorithm to select a page for replacement, okay. Now what is the advantage of this algorithm? This is the best algorithm as compared to other algorithm. Why? Because it generates minimum number of page faults. But disadvantage is what? Its implementation required prior knowledge of which page will be referenced next. Means particular page will be referenced after how many instructions, or you can say how far it is from the current instruction. So this prior knowledge is not available all the time. So practically we cannot implement this algorithm, but it is used for other algorithm as based algorithm, right? So it's all about optimal page replacement algorithm, and then next we'll discuss NRU, not recently used page replacement algorithm.